Yes, so I'm recording all of these if you want to like kind of like review these kind of questions that we're going over, okay? And again, it wouldn't be a bad idea because the CRES benchmark that we're actually going to be taking on Friday is very, very similar to some of these. In fact, it's almost so similar that like sometimes just numbers are changed around almost, you know? So it's very similar. So, you know, it wouldn't be a bad idea. All right. So let's look here at number 1. Okay, so number 1 says, in a right triangle, angle A and angle B are acute angles. Which of the following is a true statement? Okay, so we actually just kind of talked about this, didn't we, when we talked about triangles, like a triangle with two, you know, acute angles, or right triangle with two acute angles. Which one of those is going to be correct? So, Lindsay, go for it. You say C? All right, Evan, what do you say? What do you say? Yeah, exactly right. It's C. Yeah, right. That's what we just talked about, right? If you need to there, what might be helpful is for you to just draw yourself a little right triangle, okay? Now, you know, we can't just put any random numbers in here, right? But we do know, like, some special, like a right triangle that's like 3, 4, 5, right? That's a right triangle for sure. It's a Pythagorean triple. You can just draw that in there. We call that angle A, that angle B, and we'll call that angle C. And then just C. Cosine of A here, all right, with the setup that we did, cosine of A is 3 over 5. Tangent of B is 3 over 4. Well, those are clearly not equal, so that one can't be right. Right? And you can go on so on and so forth for the rest there. Tangent of B is 3 over 4. Cosine of A is 3 over 5, which is really weird. A and B are just, yeah, they're flipped, so it's like, nice try there, test, we're on to you. All right, so, but there it is anyway. Same thing for letter D, right? Sine of B is not the same thing as tangent of A, but certainly sine of A is the same as cosine of B. Sine of A is opposite 4 over hypotenuse 5. Cosine of B is adjacent 4 over hypotenuse 5. Okay? So that's it. All right. Number 2 is also a trig problem, so we'll scoot on to that one there. All right. And it says here, Frederick Middle School and Frederick High School are only 32 feet apart. The height of the taller school is 45 feet. The angle of depression from the top of the taller school to the top of the shorter school is 10 degrees. What is the height of the shorter building? Round your answer to the nearest whole foot. So what might be helpful for us to do here? What might be a good strategy to employ here? Yeah, draw a picture, right? Yeah, make a diagram of this because this is kind of hard to keep on track of, okay? So we have two buildings. All right, we have Frederick Middle School and Frederick High School. It doesn't say which one is taller and which one's shorter, so I'm just going to assume Frederick High School is going to be the taller one because it's a high school, and middle school will be the shorter one. So I'll just draw like a taller building here, and then over here I'll draw a shorter building. Okay. And so let's see, we're told some information here. Frederick Middle School and Frederick High School are only 32 feet apart, so the measure between them is 32 feet. The height of the taller school is 45 feet, so the taller school there is 45 feet. The angle of depression from the top of the taller school to the top of the shorter school is 10 degrees. So an angle of depression means we're going to be looking from the horizontal, which direction? Down, right? Depression, down, okay? So if we think about Frederick High School, we kind of like, I'll draw like a little horizontal there, like an imaginary horizontal. We're going to go down 10 degrees so that we're looking at the top of the shorter school. So this is an angle of 10 degrees. Okay? And then we want to find the height of the shorter building. So we want to find this height. So we'll call that x because we don't know it. Oh, sorry, you can't see that. There it is. Okay? Okay. So I said this is a trigonometry problem, which means there should be a right triangle in here, but where is that right triangle? How can we kind of create a right triangle here? There's kind of two different ways to do it. Patrick, you have an idea? Yeah?
Down to the side of the middle school upward.
Okay, so go up like this. Yep, so this is one way we could create a triangle here. We can create a right triangle going this direction. Okay, Alternatively, we also could have extended out a horizontal from Frederick Middle School, from the top of Frederick Middle School, and made a right triangle over here as well. Either way, we're going to end up using the same kind of measurements and stuff like that. Okay? So, we have a 10-degree angle here in this right triangle, right here. What other measurements do we know about this right triangle? Anything else?
With 32 feet.
Okay, so yeah, Hunter, is that what you're going to say? Yeah, so 32 feet across the top there, that's right. So that's a 32 feet measure. Whoa, I'm like getting ahead of myself. There we go. 32 feet. So that's like from there to there. All right. Yeah. The other angle is 80, so that could be helpful too. We could kind of choose which angle we want to use. And then that's all we really know, right? We want to find this height, and we know that the full height of the building here is 45. So if the full height is 45 and this piece is x, so like for example, this full height from here to here, that's 45, and then from here to here is just x. Okay, what's this length then? Yeah, it's 45 minus x for this side right here. All right? And so now we have enough information actually to set this up. All right? So how do we relate angles and sides of a right triangle here? What do we use to relate angles and sides of a right triangle? Yeah, Hunter?
So we have a tangent of 10 degrees is equal to 45 minus x.
You got it. Yeah, tangent of 10 degrees is equal to 45 minus x all over the 32 there. Exactly right. That's the setup. Okay, so questions on where any of that came from? Questions on that? We're all okay with that setup there? Okay, it's a little bit funky because, you know, we got two buildings here, they're different heights, and we were trying to find the one height and all that stuff, but that's setup. Okay, and so perfect. Exactly right. Okay, and so then how do we go about solving this? Tanner, how can we go about solving this equation here for x?
You could times both sides by 32.
Yep, so we'll start by multiplying both sides by 32. To start getting the stuff away from that x there. I'm going to go ahead and put that in my calculator. 32 tangent of 10 is about 5.6, we'll say. Okay? And then what? Subtract 45. So I get negative x over here equals negative 39.4. And so you get, yeah, x equals 39.4. Okay? Sorry, I'm kind of like invading this other problem's space here, but there we go. So yeah, so D is the answer, right? And that's okay because it says round your answer to the nearest whole foot. And 39.4, the nearest whole foot is 39. So there it is, 39 feet. Questions on number 2. That one was a little bit funky, but that's the idea. All right, we're all good on that one? All right, number 3 is also trig, but this is just a setup. We have to be careful here with the way this is set up. Okay, so we'll read the question here. So it says, number 3 says, an airplane takes off at the Frederick Municipal Airport. The pilot began a 7-degree ascent at a height of 952 feet above sea level. So that means that the plane on the ground before it took off was already 952 feet above sea level. Okay, like right now, right? We are, even though we're on the ground, we are, you know, a couple hundred feet above sea level right now. Okay, so this plane, it was on a, you know, an airstrip or whatever that was 952 feet above the sea level. And so then it says the cruising altitude of the plane is 2,794 feet above sea level. Okay, at the start of its ascent, which of the following diagrams could be used to find the distance the airplane will travel to arrive at its cruising altitude? Okay, so yeah, Evan?
B.
So you say B, and yes, that is the answer, okay, it is B. So why did you say B here? Why not A? It says the plane has to be 2,794 feet up into the sky.
That's from 0. If the plane is already 952 feet from sea level, then you should subtract that from how high it's going.
Exactly. The plane is already, when it starts off on the ground, it's 952 feet above sea level. So to get to a cruising altitude of 2,794 feet, it only has to go up this vertical amount of 1,842. Okay? And then the distance that it's going to travel is this hypotenuse, right? It's going to fly along the hypotenuse there up to the cruising altitude, 1,842 feet, at a degree of 7 degrees for its ascent. So yeah, it's B there. All right. Questions on that one? That one's a little bit tricky there with that, but we're okay on that. So yeah, 3 is B. All right. Cool. Let's see here. The next one is at number 9. Okay, it's also a trig one. Okay, so number 9 says select a set of side lengths that could not correspond to the triangle below. So now, how are we going to tackle a problem like this? What are they really trying to get us to use here? Yeah, Evan?
Well, it's a 30, 60, 90 triangle.
Ah, it's a special right triangle. That's right. It's one of our special right triangles. Okay. And so then again, how are we supposed to? So how can we use that
The
then?
hypotenuse is 2x.
The hypotenuse has to be 2x. Okay.
The small side is x.
Let's-
Yeah, that's right. And then the other side is x.
Okay, x squared root of 3. So this is a special right triangle, and so anytime you have a special 30, 60, 90 triangle, the sides have to always be in this kind of relationship. So how can we check to make sure, for example, that letter A works or does not work? What could we do here? Yeah, Elizabeth, go ahead. Okay, so which one do I plug in where? For example, letter A. Yeah, that's right. You're right, exactly. And also, if we remember too, x is opposite the smallest angle, and the smallest side is always opposite the smallest angle in a triangle, any triangle. So in this case, x is got to be small. So that in this case, x is a 5. So if I plug 5 in for x, 2 times 5, well that's 10, and that's one of my side lengths. And then 5 times root 3, well there it is. So does A work? Yes. So we don't circle it, right? Because we're looking for the ones that could not correspond, do not work, right? So let's look at B. All right, so 2 is our x. 2 times 2 is 4. Ooh, there it is. That's the one that doesn't work. Okay, so letter B. If we look at C, just to make sure we've got it okay, I plug in 2 for the x here. 2 times 2 is 4. There's 4. And then 2 times root 3 is 2 root 3. So C works. And then letter D, even though it's funky looking, it actually does work here. 3 root 3 is the smaller side. If you're ever unsure about that, you can just use your calculator here and just type in 3 square roots of 3. It's 5.196 there. 6 square roots of 3 is 10. So you can see they're in order. 3 root 3 is the smallest, 9 is the middle, and then 6 root 3 is the largest. Now if I plug those in, 3 root 3 in for x times 2, that'd be 6 root 3. And then 3 root 3 times root 3, well, the square root of 3 times the square root of 3 will become just 3 square roots of 9, which is, yeah, just 3 times 3, so it ends up with being 9. So 9 is the middle side there. So yeah, it is B. It is B. Okay? Questions on any of that? We're all good there? Okay. Will you have the special right triangles drawn for you on the board by Mr. Widmeyer on the CRES test? No, you will not. So you'll need to know those relationships. You need to remember them, okay? I will also not be able to write up SOHCAHTOA. You'll need to remember that, okay? Don't spell it incorrectly, okay? Don't do what Mr. Widmeyer did back in the day. All right, last one, number 14. And then I'll give you guys your assignment, okay? That's pretty much it. We have one free response question here, though, to tackle. 14 says, you are building a ramp for a loading dock. The length of the ramp is 3 feet longer than the height of the ramp. So you can see right there, there's the length of the ramp, there's the height of the ramp, so we call that x, then the length of the ramp is x plus 3, okay? The length of the ramp, oops, I should say the length of the ramp along the ground is 9 feet. So you can see that labeled in there right there too. Find the length and the height of the ramp. Use mathematics to explain your answer. Okay, so let's see here. So Zishan, any ideas here about how you can solve for one of the missing sides?
For the height, since this is the length, the bottom part is 9.
Mm-hmm.
It's 3 times longer than the height. You could do 9 divided by 3.
So how do you know the height is 3 times long? Oh, I see what you're saying, because it says right here the length of the ramp is 3 feet longer than the height of the ramp, that sentence.
Yeah.
So be careful. It's not 3 times this length, it's 3 times the height. So, or sorry, it's 3 plus the height. So it says the length of the ramp. This is what they're calling the length of the ramp.
Oh.
Like, because that's like the actual like ramp part, and then the length along the ground, that's 9 feet. So yeah, so there's our relationship there. So how can we relate all 3 sides of a right triangle together? What can we do? What do you think there, Zishan? What do we have to relate all 3 sides of a right triangle?
We could use sine. Or
So we could use sine, potentially, it's a right triangle, but we never take sine, cosine, or tangent of the right angle, and we don't know either of these 2 angles. So we wouldn't be able to use sine, cosine, or tangent here. So what's the only other option we have when we deal with right triangles? What's another thing that we have to relate?
Pythagorean.
Yes, and believe it or not, that's going to work here. Yeah. So set it up for us here, Zishan. What's it going to be?
9 to the second power.
9 squared
Plus x squared.
x squared equals?
Parentheses x plus 3 to the second power.
Yeah, that quantity squared. All right, so 9 squared is easy. It's 81 plus x squared. And then x plus 3 quantity squared.
That's like you have to put it.
Yes, very good. Exactly right. We have to foil that out there, Maria. So remember, x plus 3 quantity squared is the same thing as saying x plus 3 times x plus 3. Okay? X plus 3 quantity squared is not equal to x squared plus 9. Okay? Don't think you like distribute the x squared. Don't think you distribute that square through there and make it x squared plus 9 like that. That's not true. You have to foil it out like Maria said. So Maria, would you mind doing that for us, please? Hold on. Okay.
I have to like write it on my paper. I can't let you look.
Ah, yeah, I know. It's just too ugly.
Pretty much. But, would it be like 2x?
Okay, so x times x is not 2x. There you go, x squared, and then plus 3x, okay.
Plus 6. Plus 3.
And plus another 3x, plus 9. And so if we combine our like terms there, we end up with x squared plus 6x plus 9. Okay? And before you guys have a heart attack and you're like, it looks like we're going to have to like factor and stuff here. Actually, okay, what's going to be our next step here, Lindsay? What are we going to do to continue solving this equation? Yeah, exactly right. The x squareds very kindly cancel themselves out. And so we're left with 81 equals 6x plus 9. And now we have a very simple equation. Subtract 9 from both sides. We get 72 equals 6x. Divide both sides by 6, and we get x equals 12. Yeah, 12. Okay. So x is 12. And that means the hypotenuse here is, is 15. That's right. Okay, very good. All right, questions on that? All good? Okay, cool. Then letter B here says, find the angle of elevation, theta, of your ramp from the ground to the top of the ramp. Round your answer to the nearest tenth of a degree. Use mathematics to explain your answer. Something to show your work, basically, in this case. All right, so Julia. Any ideas here how to set this up? How can we find angle theta?
Could it be like the inverse of something?
Yeah, so which trig ratio do you want to use here? Great answer! Alright, actually any of them would work here because we have all 3 sides, so really any of them work. Alright, so cosine of theta equals what?
9 and 15.
Beautiful, exactly right, 9 or 15. Okay, very good. And at this point, right, if we want to get just plain old theta by itself, this is where we use that, what? Yeah, the cosine inverse command there. So, just like you said there earlier, Julia, that's right. So cosine of 9 over 15. Make sure your calculator is set into degree mode. Mine gets changed around because of calculus. 53.1 degrees. It says to round to the nearest tenth of a degree, so we'll say 53.1. Okay? So there it is. Good job. All right. Almost done here. let's see here. So letter C says, after a while, you realize this ramp is too long. You want to design a shorter ramp with the same angle of elevation. Sketch and label the dimensions of your new ramp below. So, how can we make a shorter ramp but still maintain that same angle of elevation? Elizabeth, what do you think?
You can change the sides, the one up above and below, but not the one across.
So, we want to, so you're,
You can shorten them, but you can't, like, change anything about the height because that's
so, okay, so you want to leave, oh, I see what you're saying. You want to leave 12 alone, right? But you want to shorten up these two. Okay, so if we do that, though, that's going to make us move that angle in more, and that would open it up wider. So I mean, on the right track there. All right. So what do we? Oh gosh, Tanner, I'll go ahead.
If you divide all the sides by like half, then you can see the same angle.
Okay, so be careful what you say there. If we divide by a half, we're going to end up. So we want to divide by 2. There you go. That's right. Yeah. If we just have all these numbers, that will result in a similar triangle, which will maintain the angles. Yeah, Evan?
We could also divide them all by 3 and get the upper.
Exactly. We could also divide by 3, and there wouldn't be any decimals involved there. These all do divide by 3, but divide by 2, still okay. Could I divide by 4 here? Yeah, really. You can actually divide by any number you want as long as it's, bigger than 1. Okay. So I mean, if you wanted to, you could even divide by 100. You'd have like a teeny tiny ramp there, but it would still be maintaining all those angles. So let's do the divide by 2 since that's what Tanner said. But if you want to do divide by 3, that's up to you too. That's fine. Okay, it's your ramp. Just make sure it's smaller, but it maintains the same angle of elevation. So we've got let's see. If I divide by 2, I get 6, 7.5, and then 4.5. Okay. All right. So yeah, perfect. That would have the same angle. Has to. All right. And then letter D, and this is like a bit of a proof, but not really here. So it says use the criteria for triangle similarity, that is angle, angle, side, 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 or side, angle, side, and justify why the triangle that we formed here in letter C is similar to the original ramp there. And so, Michael, how can we show that?
Would you do side, side, side?
Yes, exactly right. So side, 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 and then how can we show that they are similar using side, side, side?
The ratios for side to side.
Okay, so yep, so give me a ratio.
So I did 5 and 3, so
Okay.
5 over 15.
So you just have 5 over 15. In my case, it'll be 7.5 over 15, but yep, the hypotenuse over the hypotenuse, and that should equal, what else? What other ratios?
3 over 9 and 4 over 12.
So in my case, 4.5 over 9. In my case, 6 over 12. Okay? So you have to check all 3 pairs of ratios there. Just checking, just showing me one ratio, that's not enough. They all need to be the same, so to show that all 3 ratios are equal there. The ratios of the sides are equal. So, 7.5 divided by 15, that's 1/3. What am I doing? 1/2. Sorry, goodness gracious. 1/2. 4.5 divided by 9, 1/2. 6 over 12, 1/2. And so, check. They're similar by side, side, side. Okay? The 3 pairs of corresponding sides are proportional. So the ramps are similar by side, side, side. Okay? And that's it. Questions on any of that?